this one, then times the derivative of g of x. Okay, let's see some examples. Too familiar with this differentiation formula called chain rule. Music. Okay, find the derivative of this function, f prime of x. Okay, here we obvious x. First is mapped to x squared plus 1. So you can treat this as a polynomial function. Then have the square root. If this is u, then this is the square root of u. First this one, then square root function. Square root means a power function with the exponent 1/2. So we differentiate this first. At this number times the derivative of this one, 2x simplify, this is the square root of x squared plus 1 and as denominator. And 2x here. Oh, 2 and 2 can be cancelled. Amazing, huh? The concept is just the product with two numbers. A rate of change, a rate of change. Their product means the rate of change of this one at x. Okay? The square root. Because minus 1/2 means okay, yes. Means square root at denominator. So we have a square root here. Well, so you have to recognize which one, which function is applied first, polynomial function. Which is the last? This one. So we differentiate the last one. Then times the inside one, the derivative of inside one. Okay. So the form here is x is mapped to g of x first, then f last, the second or last. So we differentiate f first at this number times the derivative, the inner one. This is outer one, the inner one. Okay. Example 1. Then example 2. Differentiate a, y equals sine of x squared. Here, x is mapped to x squared. So first we have a polynomial or a nominal. Then sine. So we can find y prime by differentiate sine first. We obtain cosine, the last one, at here. Times the derivative of this one, 2x. This is a. For b, x is mapped to sine x. Oh, trigonometric function first. Then squared, a power function last. So differentiate the outer function, the last function, 2 times this one times the derivative, the inner one. The derivative sine is cosine. Wow, very good. Cool, huh? Chain. Generalize what we have learned about multiplication. Aha, we had learned this before. I still remember a function f power whose derivative is n times yes, this is a special case of the chain rule, because x is mapped first by the inner function f, then by power function with exponent n. So differentiate this one, we first differentiate the power function n times this one raised to the n minus 1th power at this number times the derivative of inner one, f prime x. Okay. Do you remember this? Yes. We have learned this before. And this is a special case, a very special case of chain rule. A function composed with a power function. Anyway, y prime equals x back to this first, then the last equals 199th power times the derivative of this one is 3x squared. So 300x squared times x cubed minus 1 raised to the 99th power. So you can see almost all formulas or theorems are under very mild or gentle conditions. Just like the differentiation rule of sum, difference, product, and quotient, all in the very mild condition. Just differentiable at some number, at the corresponding number, then we have this result. Okay. Here. Wow, this is a fraction, but rewrite this as a power function. This is x squared plus x plus 1. Square root, cubic root means raised to the 1/3, but in the denominator, so the exponent is minus 1/3. Okay, x is mapped first by polynomial function. Second, by power function, with the exponent minus 1/3. So differentiate this with to differentiate the power function first. Power rule decreases the exponent by 1, then times the derivative of this one. Then this is at this number. Express this as the root minus x squared plus x plus 1. Minus, make this one at the denominator and 4th power. And the 1/3 is the cubic root. 2x plus 1 is in the numerator. Okay? No? By the definition of rational power, this means that the nth root of a, the nth power, or these two are the same. But now, because n is a negative number, minus 4 means oh yes, 3, yes. I missed this factor. Sorry. So the problem is here, not this one. Huh? Thanks. Good. Find the derivative of g of t, g prime t. Okay, t is mapped to this quotient, this fraction first, rational function. Then the power function with exponent 9. So g prime of t equals, we differentiate this power function first at this number times the derivative of this one. This time we use a quotient rule of the differentiation formula.